So an Angular application is a single page application that's served from index.html. And the code that starts from main.ts. And I mentioned at some point that when we render an application, especially something that renders, we need to render some sort of a tag, let's say a div. Let's say it's an HTML tag. And this tag serves as a root component or a root tag. When I say component, all I mean is custom tag. So if a tag is, for example, is div, I call this div native component because this is something the browser can understand. But if I have a tag called weather, there's nothing called weather. The browser doesn't understand weather. So basically, you have to define this component or this tag to teach the browser how to render this weather component or weather tag. And while I can render just components in my application, what I'm going to do is to render a module or an Angular module, and Angular module is going to render a component for me. And then this component will render other component, and we build an application. So I was trying to answer, why do we need to create this Angular module? What's the benefit of Angular module? And here are, so what I like to do is to create a module. We call it Angular module. How it's different than JavaScript module? An Angular module encapsulates certain Angular objects and expose some Angular objects for other people to work with. By creating this bubble and having all these Angular objects inside, we create some sort of scope to all of these objects to work together. So that will represent some sort of a feature in your application. For example, I need to have logic to represent the payment. In order to pay, you need some service to pay, you need a component to show the payment form, you need some sort of component to show the user their balance, if they do have a balance or not. So you put all of these objects in Angular payment module. And then you don't need to send this module right away to the browser. In order to pay, all you need to do is to import the payment module and have this logic rendered in your app. So as you can see, every Angular module will represent some sort of feature at some point in your application. So that's basically the benefit that I get when I create an Angular module. I create a scope full of other Angular objects, which will help all of these objects to work together to represent a feature in your app. So when we start an application, I showed you here that main.ts is bootstrapping app module. App module is a class that's exported from this file. If we take a look at app module, I see it's just a class. But this is not just a class. This is an Angular module. Why? Because I decorated this with add-ng module. So I converted the class from being just an empty class to become superhero. How? By mentioning the decorator, and I pass to this factory decorator some settings. The settings basically is defining what's inside this bubble that I create. So I created a bubble called app module. Main TS is pointing to this. And now from within this, I declared an object called app component. And I imported some logic from another bubble called browser module. And browser module is important. Why? Because it gives me all the if conditions and for loops and other logic that I need in my application. So we needed to import this Angular module. Note how this import is different than this import. This is a physical import to import the class, the JavaScript file. This import is to import another Angular module. Okay, so basically a browser module is another bubble that holds other objects I'm using now. And providers we will use in a few days. It's used for services. We will explain what are services later. And I see that I bootstrap my application from something called app component. Any questions so far? Let's take a look at app component. What is it? And a component is a tag, a new tag that you teach the browser. So in order to create a component, we need at least three things. One is a tag name. We call the name selector. Two, I need some data. Maybe my data is just an array that has 1, 2, 3. And another thing, what we call templates or view. Basically, the template or view is to describe how do you want this data to be present at the DOM. So you say, I want this data, every single number, to be rendered inside a list item. So I define how this data would look like. And that's basically the concept of a component. Every component will have selector, will have a view or template, and will have what we call state. State represents the data that this component has. Let's take a look at the app component. App component is simply a class that's decorated with add component. So this is not just an object. It will be just an object without the decorator. Now this is just an object, but the moment you decorate this with add component, it becomes an Angular component, Angular object. And this object is defined inside an Angular module because it's declared here. And also this object is the one that you bootstrap. Since this is the one that I bootstrap from, the selector of this component should be mentioned inside index.html because this is the one that renders the entire application. And here I can describe inside the template how this component looks like. So you see that every component has three parts. State, it has a selector name, which is the tag name, and it has a view or template, which describe what need to be displayed basically. And if I need this property to be displayed in the view, you need to add double curly brackets. So what I can say is here, render a paragraph, and inside this paragraph, render title. And now when I save, you'll see that Monday is rendered. So what I did is I created what we call binding. And this is one-way data binding, state to DOM. Because everything you put inside the template ends up as objects inside the DOM. So in order to display data from the state into the DOM, we use this double curly brackets around it. And that will evaluate this property and print the string Monday to the DOM. And you need to know that magically, every single time this title changes, Angular automatically changes the DOM. So for example, let's say inside the same class, I have a constructor, and inside this constructor, for example, you set timeout, and let's say after 3 seconds, I want my state to change. This dot title. Now, as you can see, 1, 2, 3. Now Theo is a good boy. So all I did is I changed the state after 3 seconds. I didn't play anything with the DOM. However, if we looked at Angular, what Angular did, Angular knows exactly this paragraph, and it knows that the value is Monday. And if you noticed here, this change only reflected the paragraph content. Let me refresh again. See Monday, after 3 seconds, only the content of this paragraph will change. So whenever you change the state, Angular automatically changes the DOM for you. And that's basically the how an application is rendered from an Angular module and an Angular component into a DOM. The story starts with main TS, where we bootstrap a module. You can at any time load immediately a component. You don't need a module. But we like to have a module so we can encapsulate some logic together. Especially now, I'm going to create another component. I'm going to call this component Theo. So I'm going to open another tab here. I'm going to create a new component. So I'm going to generate a component, which I'm going to call Theo. Now, minus minus flat is just not to create another directory. Because if I remove the flat, Angular is going to create a directory for this Theo. I don't need that. Now, as you can see, two things happened. Theo component was created, and it has a selector called app Theo, and Angular module was updated. So as you can see, this bubble now has two components, and they know each other. So inside app component, I can render immediately Theo. And now Theo will be rendered. Theo works, which is the text that was printed here. Let me call it just Theo. So as you can see, Theo was rendered immediately because I used the selector name inside app.js. So all these components now know about each other. I don't need to import export components. So this is why I do appreciate having this module that encapsulates this logic together. Now Theo may have its own states. Could be Boolean value. Okay. And I can render this Boolean value in the template by using the double curly bracket, and I see true printed at the DOM. Any questions so far? To recap, before we go to a break, an Angular application starts by pointing to a module. We call it the main module or app module. This app module, it's different than a JavaScript module because what it holds inside is Angular objects, and it imports other Angular module logic. So now, what is an Angular module? Angular module is a simple class or a simple object that's decorated with ng module. What is a component now? What defines an Angular component? An Angular component is just a class. As you can see, it could be just an empty class, but this class is decorated with add component to make the component, to make this class an Angular component. And remember that every component has three things: selector, view or template. The view is basically what represents the DOM. Everything you put here is rendered at the DOM. And we have state. And the state is basically your data. And inside the template or the view, you describe how the data looks like. And we can always create some sort of binding by adding the double curly brackets in the template to render, to evaluate a property and render its value. Any questions?
Yes, Professor, I have a question.
Yes.
So the main module, which is the app module,
Mhm.
it can either wrap other modules which are like which have other components, or it can have multiple components.
Yeah, so every module, Angular module, doesn't hold other modules. It holds components, it holds directives, it holds pipes, it holds services, and all of these are objects, 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 objects. All of these objects are decorated with Angular decorators to make them Angular objects. And this is also encapsulating all of these objects together. Why we do that? Just because this code represents a feature, for example. Now, once you create a feature or certain logic of code, you can just encapsulate all of this in a module like this one and reuse it in other Angular modules. So you can create now another Angular module that holds other stuff. But what if I need this component or this directive or this service? Then you import this module here using the imports syntax that we saw in this file. And now you get access to whatever exported by this module. Is it clear?
Yes, thank you.
Sure. Other questions?
Professor, how many, I mean, uh, can I create as much as need of my
Very
module?
good questions. Very good question. Uh, Basically, if I create, if at the end you are serving your code to the browser. So let's say this is a browser, and you're going to have code, 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 code. Whether this code is in separate modules or in one module, at the end it's sent to the browser. So if you are putting all of these modules in a single JavaScript file, at some point, this application is going to give you a warning. If I look here at angular.json, I can scan this Angular configuration app, and I see that I have some sort of budget. Here it is, budget. And we have certain limit to the size. Of course, you can increment this, but I mean, if the maximum initial bundle that you create exceeds 1 megabyte, you receive an error, whether this in a separate module or same module. So you don't want to write really big logic. But look at this, it's called initial. So what does this initial mean? We usually, as I mentioned, we separate our features inside multiple modules, and we serve only one of them to the browser. So we render, for example, the dashboard and the welcome screen. And at any point, we need to load, for example, the shopping cart. The user clicked on shopping cart. Then we fetch the shopping cart module, and we render the shopping cart logic at the DOM. We call this technique lazy loading. And now with the lazy loading, you don't have any basically limitation to the size of how much code or modules you can create. You can split your application to unlimited number of small kind of features or logic that represent any kind of functionality in your app, and you just load it on demand. Now, if you don't want to implement lazy loading and you want to bundle your entire application in a single file, then yes, you do have a limitation of the compiler budget yet that you see in this file. And you either increment this limitation or you break down your application into multiple smaller parts, as I described, and as we will do in a couple of days. Any other questions? Right? Let's take a break. After the break, we could learn about how can we communicate between two components. Let's take a break for 10 minutes. Okay, welcome back, everyone. I would like to take a quick look at this slide. Here within the slides, we see something called types of components. So we can kind of categorize based on what we have inside the component or what this component represents. We can categorize the component into three sections. We can call the component either stateful component, or it could be stateless component, or it could be used just for layout. So what are the differences between these three? A regular component that you just saw earlier is considered stateful. It has a selector, it has template, and it has some data. Data represent the state. Every single time the state changes, the template changes. But now, what if I create a component that does not have any data, just a template? And the data comes from the parent. So if the parent just provide data to another component to be rendered as a template, we call this component stateless or representational. For example, a component that's going to render a box that has shadow doesn't need to hold any data. We just pass the data from the parent, and this data will be rendered inside the box that's already decorated with shadow and border, etc. We call this kind of components stateless or dumb components. They don't have states. We usually communicate with the parent using inputs and outputs to pass data in, and whenever something has changed here, maybe we just pass the data back to the parent, because the parent is the one that's stateful and had the state and knows what kind of changes need to happen to the application if some event happened within the child component. Now, the third type of components is called layout components. And these layout components, basically, they just represent sections in the app, and they do not need to re-render. They don't need to update. So we mark them in a way that Angular skip any kind of change detection within these components, because they never communicate with any other component, and they just represent layout in the application. Some of the components that you will use in any UI libraries, they are clearly going to be some layout components because they just show you the sections of the app. Now, if I want to categorize states and see what type of state that we might have, of course, we have a state in the DB. DB is permanent state. We learned that the server should not hold any state, should be rest, which is no state persisted on the server. Now we also have an application state, and an application state can come in different layers as well. So now your application is going to be a tree of components. Now every component might hold state, and the collective state represents the application state. Also, we could have some sort of state that multiple components share and work with. This is, we call it the global state. We will create a global state tomorrow using services to show you how we can work with this global state. Today, we're going to work only with local states. So in Angular application, all the data that we have inside the components or inside the objects represent basically an application state. And at some point, this application state is rendered to DOM elements. So we also have DOM states. And now it's your job to always sync or maintain kind of sync between all these kind of states. You have your application state, which is what you need to worry about. At the beginning, you don't have any application state. So you fetch some state from the DB. And now you have some state. Now you describe how the state is rendered at the DOM. And once sometimes some user try to remove an element from the DOM, you update your application state and you send the request back to the DB server to remove the object from the DB. And if the DB returned back a response that the database successfully created the item, all you need to do is to update your application state, which is automatically reflected at the DOM, and the item will be removed from the DOM. So that's basically the job that we're trying to do right now. Maintain good state between the DB, the app, and the DOM. At first, your application communicate to log in to fetch some data. Now, once I have some data, they are rendered at the DOM. Remember, this arrow is Angular. You just have to describe some data and Angular takes care of updating the DOM. Now, sometimes the DOM fires event. Now, when the DOM fires an event, you have to pass the event to your application. The application may communicate with the DB, and as a result, the state changes. Once the state changes, Angular changes the DOM. So that's basically the job that we will be doing when we code an application. Any questions? Good. Let's take a look at the component. And we see the component. We see app component here was created with this template and this style sheet. Of course, templates and style sheet, once they become big, you can create them as external files. And the selector would be template URL instead of just template. And with the styles, there will be styles URL to point out the external file. Now, if your template and styles are within a decent size, then you probably want to create them as an inline. Now, why this component by default has an inline template and inline style? Because when I created the project, if you remember, I passed -s and -t to the command. And -s and -t basically create all components with inline style sheet and inline templates. And also I passed -S if you remember, and that's to eliminate the test files because I'm not gonna cover test in this course. So also I passed -S to skip all the test files from being created. Any questions? So my application now is rendering Asaad, which is app root, and Asaad is rendering Theo. Now what I want to do is I want to pass data from Asaad to Theo and from Theo to Asaad back. I want to communicate between a parent and a child. And this communication in Angular basically is named as input and an output. So an input is data passed from a direct parent to a direct child and not to a subchild. In order for Theo to pass it to another child, Asaad cannot pass information to Mike directly. Asaad must pass it to Theo, and Theo should pass it to Mike. So the relationship of inputs and outputs is only direct between direct parent and child, and not to subchildren. Now, how do I let Asaad directly communicate with Mike without Theo being involved? That's something we will learn tomorrow. We can create a service tomorrow that will allow Asaad and Mike to communicate without having Theo being involved in the middle. So that's we will cover tomorrow. But today we will learn how we can pass data directly between a parent and child, and the child how to pass data immediately from two components that are in direct parent-child relationship. So let me create here some sort of data that I need to pass to Theo. I'm going to have treats, and Theo likes liver and green beans. And I need to pass this data to Theo. Let me remove the title. Let me remove this constructor too. I don't need to make any change. So I have some data in Asaad that I need to pass it to Theo. So Theo first should accept this kind of data. So Theo should accept this input. So inside Theo, I'm gonna remove this good boy property. It doesn't make any sense anymore. And instead, I'm going to create my treats. And to have this my treats served as an input, we decorate this property with an input decorator. Now, this is no longer just a property. This now is an attribute that can accept data from the parent. So now I can say my treats as an attribute, and I pass the treat property to it. Let me go back to Theo now. Let me fix the import, so control space, and I import the decorator from Angular core. And now my treats need data, initial data. So I say, here is the data. How about we type it properly? So I can say colon is to add the type, and I say that this is a string array. Now Theo doesn't have any data passed to it. So the property is called myTreats. Should be the same name. Okay. And now I should pass an array of strings to it. So you probably need to say treats, right? Well, that still didn't work. Because in order to pass a property that's correctly evaluated, you need to add square brackets. These square brackets mean this property is an input, and I want to evaluate this value treat to pass this array back to Theo. Now, what if I want to pass just a string? If you just want to pass a string, then I can define, for example, shower, true, or yes, just a string. And now I can go back to Theo. I have another input called shower, which is a string. Okay. And here I can display shower. And I can pass basically shower without the square brackets. I can say shower equal yes, yes. And now as you can see, yes is displayed. I didn't need square brackets. Why? Because if you want to pass string, you can just pass it right away. Or I can just pass the shower property that exists here. And now as you can see, yes was printed with small letters. I use the double curly bracket. But that will only work for strings, because if I pass treats here, now as you can see, the array was stringified. So it's converted to string. You can only pass strings in this place. How do I pass an array? In order to pass array or any other object, you need to add the square brackets to correctly evaluate the property. And as you can see now, my treats is a correct array, because if I print the 0 element, it shows me liver. However, if I display the shower 0, it will give me just the letter L, because it's a string. So this syntax will only send strings, while this syntax will send you a correct array. So unless what you're passing is a string, always remember that you need to add the square brackets to evaluate this property correctly. Otherwise, this property is going to be stringified and passed. And that's not something you want to do. So that's how we pass data from the parent into the child. Inside the parent, Asaad, I have an array of treats. Let me remove shower. I define an input inside the child called my treats. And I pass the data of array of strings back to it. The child will receive the data and show it correctly, the template. Now, how does Angular now Theo pass something back to a set? Let's say I have here a property called love, which is true, and Theo needs to send some love back to a set. How could that happen? Or let me call it message. And Theo want to say just thank you. How could Theo pass a thank you message back to a set? Now, in order to do that, I need an output defined inside Theo, and have Asaad listen to that output. How do I define an output? I can have an output with a decorator called output, and I can give it a name, let's say a message. Okay? Now that I defined an output, now Asaad can start listening to this message. Okay? And we listen to messages using the parents syntax. Now let me go back to Theo and fix all these errors. The first error is importing output, so control space and import. And now message need a type. And the type of an output is usually an event emitter. So I need to say this is an event emitter. And I pass the generic type. Let's say I'm going to pass a string. So let me instantiate this with a new event emitter. Okay. Now I defined an output, which is an event emitter. type, and it's going to emit. Sorry, I forget to call the constructor. And it's going to emit some sort of string. So let's send this message out to Asaad. So inside the constructor, I'm going to have a set timeout. And after 5 seconds, I am going to send the message out to Asaad. So I'm going to say this dot message dot emit this dot text. So after 5 seconds, I'm going to use this event emitter to emit this text, which is thank you. Now inside Asaad, I'm listening to the message output. And once I receive a value, I'm gonna run some code. What is this code? Let's say I wanna just console.log hello. Okay, you can just run any code basically you need when you receive the message. But it is common that you define a function that is called when the message arrives. So I'm gonna say handle message. And I define handle message here. And here I can say console.log message arrived. And if I see the console now, message has arrived after 5 seconds. So everything works fine. Let me refresh. Clear. There is nothing. After 5 seconds, the message will be arrived. But how do I get the message itself? Because I'm sending here text that says thank you. In order to grab whatever the event is sending, you need to add a special variable called $event. And here I can accept this event. So here I'm gonna receive the message from type text, and I am going to print it out. Sorry, from type string, and print it out in the console. So 5 seconds, we should see the message arrived, and then the message says thank you. So $event, as you handle any output, represent the event object that was sent through the output that you define. For example, you can listen on any native event as well using the same technique. So for example, H1, I can listen on mouse over, for example. Every single time the mouse over, when I handle event, and I say console.log event or mouse. Now, every single time I pass the mouse, you can see that mouse is printed down. So how about I accept the mouse object? So I can say, hey, I want to accept the event. And here you can accept the event from type event. And now you print the event itself. Now, every time I mouse over, as you can see, the mouse event is printed in the console. What about I listen to another event? Let's say I want to listen to an event called click. In order to grab the click event, which is the keyboard event, also I pass the $event. Let's define handle click. Now I hover, click. So when I click, I get pointer event. instead of mouse event. I go back, mouse event, mouse event. But when I click, 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 I get pointer event that tells me which button was clicked and what happened when I clicked. Let's say I have an input. When you do have an input, also input has some events. So what you can do is you can listen to any of these events. Let's say on key up. Every single time the key is up, handle key. And let's grab the event. Let me define handle key. See what type this guy is. So here's what I'm getting here, a keyboard event, and the keyboard event has .key property. So it did have, so I can have, what is the type of this guy? It's called keyboard event. So I can define this as keyboard event. And here I have .key. So now every single time I type, the letter is printed down. So here are so many examples how we listen to events and how we pass data basically from two components and share data between them. Now let me update Theo. Instead of having this on inside the constructor, how about I create button inside Theo that says message to Asaad. And now every single time Theo is going to click this button, I'm going to trigger send message. And now when I send the message, I'm going to send Asaad text thank you. Now only when I click the button, Asaad will receive the message and print the message out. So these are many examples how we could pass data from in and out to components, including how I can listen to any native event as well and handle it in Angular. Any questions?
Yeah, hi, Professor. I have a
Yes.
question. So for this event, it will be handled by the JavaScript or it's handled by the event loop?
All of these events are handled by the event loop. All of these events that you're listening to, they are pushing these functions natively inside the event loop, which will be at some point pushed to the VA to be executed in order.
Yes, Professor.
Now I want to show you something. I have an input property to Theo that's showing the treats, right? How about I try to print this property out? So I say, hey, constructor, can you please console.log for me the treats? And I see that the treat is an empty array. However, I see this treat printed successfully here, 0, as a lever. So how come the constructor does not have access to the treats? Because any kind of input value is set later after the class is constructed. And for that reason, an Angular component does have life cycle functions, methods, we call them hooks. And these life cycle hooks are triggered at certain times. And we need to use them and know how to use them basically appropriately. For example, an input property is only set after component has initiated, after it's constructed. So Angular gives me a hook called onInit that you need to implement. Here it is. And now if I try to print my treats inside ng onInit, I see correct array was printed out with liver and green beans. So what we just learned is that there are some special methods, we call them lifecycle hooks, are triggered, and we could, using these hooks, read or write or control when certain values are available inside my components. Now, this input property is not available inside the constructor, because after the constructor has finished constructing this class, Angular is going to pass the value from the parent to this property. So we can grab the value of the treats only inside ng onInit and any other lifecycle hook that comes after ng onInit. So what are Angular lifecycle hooks? Here they are. We have a slide here called component lifecycle hooks. As you can see, the constructor is called once. And then we have a set of other lifecycle hooks triggered. And these are always triggered in this order. Some of them, they start with, they end with init, which tells you that these triggered only first time when we mount the component. And some of them, they don't have init, which means they trigger every single time there is a change in the states. So what are the components that triggered every single time there is a change? When the component, so we need to distinguish between three phases in the life cycle of the component. The component is being created, the state of the component has changed, and then the component is removed from the DOM. These are the three states every component goes through. So let's go with the first one. The component is mounted. Certainly we need the constructor, init, init, and init. All the init functions are triggered when we mount the component. Make sense? As you can see, we understand what is this onInit. OnInit is just one function. If you implement this function, it will be triggered. We saw that. And it comes after the constructor. We used it to read any input value, right? So now we understand what is this used for. But what about the content in it and the view in it? Now, if you have a component A and you pass anything between the opening and closing tag, this is called content. So maybe you have some content here or elements that need also to be initialized, or you have references. You grab these references only within this hook forward. This is about content. What about view? The view is the template itself. So A, remember, has selector, view, and state. Whatever references you define inside the view, you grab them inside this hook forward. So if inside the template, I define any variable and I need to read it, I can read it only here or here. I cannot read it here. I cannot read it here. So we have certain hooks that gives me access to whatever I define in the view, whatever I define inside the content, and any input value that you might need in this hook. So that's when I mount the component. What about when I change the component, the states? Let's say you have a variable x, 5, and you change it to 6. State has changed. Which of these is triggered because of the state changes? Every single time the state change, check, check, and check. The 3 checks are triggered every single time the state has changed. This one is always triggered, do check, before Angular does check what has changed. Second hook is Angular is going to check if the content of this component has changed. And the last one, Angular is going to check if there's anything in the view of the component has changed. So these are the 3 hooks that are triggered if we change the states. That leaves me with knowing when does ng on changes trigger. Ng on changes is a really special hook. This ng on changes only trigger if an input property change reference. At some point, you are passing some data as an input to this component. If this input change reference, then ng on changes will trigger. And do check and content check and view checked. So this one is also part of the state change, but it only triggers if the input has changed reference. If the input did not change any reference or you don't have input, then this method will never be triggered. Now, the last lifecycle hook that we need to know about is ng on destroy. Obviously, when you remove and mount, when you remove the component from the DOM, ng on destroy is called. And we use this last hook only to clean up any subscriptions or any kind of logic that we did here. We just destroy them inside this lifecycle hook. So part of your homework today is basically to implement all of these hooks inside the component and make some change, or just render the component and see which one is basically triggered and when, and understand this lifecycle hooks properly. Any questions? The last thing we were going to learn today is template references. So I can create a reference to any element in the DOM. How? I just add count and give it a name, my paragraph. I just created a variable called my paragraph that points to the DOM element P. That's simple. So basically, if I print out here my paragraph.inner HTML, what do you expect to be printed? Theo, and my trait's 0. Theo looked at me when I said his name. There you say Theo and liver. So basically, I literally created here a variable that represent the paragraph DOM element. And I read its value inside the template. Okay, it's really that easy. But how do I grab a reference to this paragraph here inside my application state? I'm going to use another decorator called scan the view. For a child, the child is called my paragraph. So I'm using a decorator called view child to scan the view for a child called my paragraph. Okay? And now what I can do is I can say this property name called para, and from type element ref, and the element that I'm trying to target is paragraph, HTML paragraph. And I don't want to instantiate this class, this property, sorry, with every single time I need to import, I put the mouse at the end, control space, and I have the autocomplete import the classes for me. Now, usually you need to instantiate this, so you create a new paragraph, but I don't want to do that. And now TypeScript is complaining. So I know that there is a paragraph called my para that will set a reference to this paragraph element. So in order to tell TypeScript this is okay, no initializer is needed, I'm just going to add this pound at the end of the variable name. Now this property doesn't accept any initializer, so I don't have an equal sign and a new paragraph. No need, because it's going to be set. But when do I set this property correctly? Can I read it inside ng on init? Let's see. Console.log this.para.native element.inner HTML. Can I read the paragraph value? Nope. You're trying to read something from undefined. Para is supposed to be this guy. So how come it's undefined? All right, let's try to read it after the view has initialized. After the view, either init or checked, both of them will work. Let's do it after the view init, so only once. Let me implement the method. I hover here, quick fix, implement. Now let me move this console log to be called in here. Now I try to read, here it is. I read the value correctly, Theo and liver, which tells me that the value of anything inside the view cannot be read inside the constructor, cannot be read inside ng on init. It can only be read either after the view has init or once the view is checked. So we are literally seeing all of these lifecycle hooks in action now. So as a result, for example, I can do is when I click the button, I can this dot para dot native element dot HTML. I can set it to something else, new content for the paragraph. Now I can go back to my application, close, message to Asaad. As you can see, the new content is printed correctly at the DOM. So what I did is just I created a variable in the template using the pound key. My paragraph is a variable that represents pDOM element. So I rendered it and I read its value. How do I grab this variable reference? In my class, I use a decorator called viewChild. The viewChild is basically scanning the template for a variable called my paragraph. And I created a property to represent that element called para. With this para, I can read and write anything to this pdom element and make changes to it. Any questions? So what I wanted to learn from today's lecture is basically, literally mastering two things. The first thing is understanding inputs and outputs. Remember, if we have two components in direct relationship, we pass data from the parent to a child through an input, and we pass data from the child to parent through an output. I wanted to master this relationship. And in today's homework, once you clone the homework, you will see that we will create his app component. You will create child 1 and child 2. And the requirement of today's homework is to pass data from child 1 to child 2. So far, what we learned is we cannot communicate between two siblings. We didn't learn how services work yet. So the only way to send a message from component 1 to component 2 is to pass the message as an output to the app, and the app to pass it to component 2 as an input. So you have to pass it up, and then it goes back down. That's the only way we can communicate between component 1 and component 2. So once you create this relationship, basically you literally master inputs and outputs. Main objective of today's lecture. Now, the second thing that I wanted to master is lifecycle hooks and understand them, which one is triggered when. So in order to do that, also the homework tells you to create an application, and with the application, I want you to implement all of the hooks. So you implement every single hook in Angular and just add a console log that this hook is triggered. Now, you have to distinguish three phases: the mounting phase, state change phase, and the unmount phase. Currently, we didn't learn how we unmount a component, so you probably can skip the unmount because you're never going to see it because the component just mounts. But what we can see is which hooks are triggered when the component mounts and which other hooks are triggered when the state changes. And with this, basically, you really understand what are these hooks and when they are triggered each. Now, we will be using this paragraph viewChild references a lot as we code in the application. So you will master this at some point with time. But understand how they are created and how we grab reference to these template variables. We call them template variable. That's what I wanted to work on this afternoon. Any questions?